Hello grade 11. Now I know we don't have a lesson today, but I'm still going to post this video because in yesterday's live lesson, I think there was a one of the questions, assignment question 3, we ran into some problems and I saw that there was a quite a silly mistake that I made over there, so I want to clarify that. Okay, so I'm going to start from the beginning of this question. The graph of the quadratic function has a vertex at 5 over 3, 1, and one intercept is 2 over 3. Okay, so first of all, the vertex is going to be at 5 over 3, 1, and then the intercept is 2 over 3. So if I'm going to quickly sketch out what that function looks like, what the graph looks like, okay, I have 5 over 3, 1, the coordinate 5 over 3, if I'm going to use decimal, is going to be 1.61. That is the coordinate over here. So the vertex is at, if that's 1, 1.61 is around here. That's the vertex. And the intercept, x-intercept, meaning that the x value is 2 over 3, which is 0.6, and then 0. And so 0.60 is around here. So this graph, you can tell, should look, if I'm going to sketch it, just a rough sketch, should look something like this. Okay, so that's what we're guessing the graph would look like. Now, we want to determine the equation of the function in standard form. Standard form means standard is vertex form. Okay, so our vertex is at 5 over 3, 1. That means there's a transformation of 5 over 3 units right, to the right, and also a vertical 1 unit up. I'm just going to say 1 unit up. Okay, so our graph is going to be a of x minus 5 over 3 whole squared. Now, I probably forgot about that square yesterday during that live lesson, and then plus 1. And then we want to put in the coordinate of the x-intercept into our x and y values. And so when I put that in, we're going to have y equal to 0, and then a of x-intercept is 2 over 3 minus 5 over 3 whole squared plus 1, and then we're going to have 0 is equal to a times 2 minus 5 is 3. We're going to have negative 1 squared plus 1. And so when we squared a negative number, this is where I went wrong. I forgot that negative squared becomes positive, so we're going to have 0 equals to a plus 1, which means that a is negative 1. Now when I put this negative 1 back into my equation over here, I'm going to have y equals to negative x minus 5 over 3 whole squared plus 1. And now this makes sense because this graph is negative. It is symmetric, it is mirrored, it has a reflection, a vertical reflection. Okay, vertical reflection means that it has been reflected vertically. Okay, so that's a vertical reflection. And now we've done it in standard vertex form. This is the standard vertex form, part A. And then for part B, the general equation, part B, will be, we're just going to expand it out now. Y equals to negative x squared minus 10 over 3x plus 25 over 9 plus 1. Okay, that's the, we have to expand out the bracket. Y equals to negative x squared, and then we have plus 10 over 3x, and then we have minus 25 over 9 plus 1. Minus 25 over 9 plus 1 is going to be 16 over 9. So y equals to negative x squared plus 10 over 3x minus 16 over 9. Now 1 is the same as plus 9 over 9. So it's negative 25 plus 9, which is negative 16. Negative 16 over 9. So that is the equation in general form. Okay, this is part B in general form. Now, in part C, it says state the other intercept. Now, let's continue from where I got stuck yesterday. Now, first of all, we can try to factorize it first. We're going to try first, and then if it doesn't work, then we're going to have to go back to the vertical form, the vertex form, and then factorize it using a squared minus b squared. Okay, so in this case, we have y equals 2. I'm going to multiply both sides by 9. To find the intercept, we're going to set y equals 0. 0 equals 2, negative x squared plus 10 over 3x minus 16 over 9. And then when I multiply both sides by 9, 0 times 9 is still 0. We have negative 9x squared. And then plus 30x, because 9 times 10 over 3 becomes 30x minus 16. Now, from here on, let's see if we can factorize it. Negative 9 is 3 and 3. One of them is negative. And then 16, probably one of them is going to be, one of them is negative as well. We have 4 and 4. Let's see how that works, okay? Let's try negative 3 times 4. That's going to be 12, and then 3 times 4 is 12, and then when you add them together, that's not going to be 30. So is there a way of doing this? I'm going to try a few ones. Let's try 8 and 2. 8 and 2, we want to get negative positive 30. So negative 3 times negative 8 is going to be 24. 24 plus 6, that works, okay? So this one should work, okay? So we have negative 3 times negative 8. That's going to give us positive 24. Positive 24 plus 3 times 2 is 6. It's 30x. So we are able to factorize it, okay? So 0 is equal to negative 3x plus 2, and then we have 3x minus 8. Now, just to be safe, let's go over the answers again. So we have minus 9x squared, and then here we have positive 24x, and then plus 6x, which will give us 30x, and then we have minus 16, so that is correct. Now, let's now factorize. We factorized it. Now we're going to find the x-intercepts. Then we're going to set negative 3x plus 2 is equal to 0. That's one of my solutions. And then we have 3x minus 8 equal to 0. That's my other solution. And then what I'm going to do is I'm going to solve for both. That's a plus. So we have 3x equals to 2, x equals 2 over 3. This was actually our first solution that it gave us. X is 2 over 3. Okay, that was the first one. And now for the second one, 3x is equal to 8. 8x is equal to 8 over 3. This will be our other x-intercept. Okay, so that's our other x-intercept. Now, for part C, that's part C. Now for part D, it says state the domain and range of the function. We have to find out what that maximum value is. So what is this coordinate? So I'm going to set this coordinate. The vertex is at 5 over 3, 1. Okay, since the vertex is 5 over 3, 1, it means that the maximum value, this is the maximum value, because y cannot go over 1. Y does not go over 1. It just stops over here. It goes from negative. It goes up, 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 up. And then it stops at 1. And then it goes back down. So the domain, x, is a subset of real numbers because x can take any number at all. But then y is going to be less than or equal to 1. So you write that. That is the domain. And then the range is this one. And then lastly, for E, state the equation of the axis of symmetry. We just have to look at the x coordinate over here. What is that coordinate at the vertex? That's going to be 1 over here. That's 1. Let me just clear this up. That will be the equation of the symmetry. X is equal to 1. That is the symmetry. Okay, so that was question 3 of the assignment question. Hopefully that clears up some misunderstanding, and I will see you all on Monday. You will have a formative quiz. I will post that on Power School, so please work on that. And then after that, the next lesson after that, I will go through the solutions of the quiz. Okay, so that's it.